The review of scientific methodology is the most important lecture in the course because it defines how you're going to write your final paper. In this course, we're going to apply the positivist methodology. We're going to use this scientific approach primarily because it is expedient, it is useful, and not because of its philosophic validity. Now, pure scientists often ridicule the social sciences, like political science and psychology and sociology, because we are less precise. We, for example, can't specify chemical reactions or when steel will bend under certain temperatures. So it's fine that the physical scientists can solve these scientific puzzles, and they bring us inventions like nylon and steel and other materials. But the advance of the physical sciences has not allowed them to predict which battles would be won or lost. It simply made those battles more violent. Pure scientists are not equipped to solve these types of grandiose social problems. That's where the social sciences come in. In fact, most pure scientists tend to have extremely oversimplified solutions to complex global problems. And that solution is almost always simply achieve world government without explaining how. We can make a distinction philosophically between the physical scientists and the social scientists in the ways that we would compare clocks and clouds. Clocks have a specific number of gears that are of a certain dimension, and with math we can make very specific predictions about where the hands will be on the clock over time, because the clock can be described by very specific formula. In contrast, social scientists study large groups of people that interact with each other in complex ways, and that kind of behavior is much better represented by a cloud. A cloud is amorphous. We're never sure what shape it's going to be, but it does have a completely set mass. It's got a certain number of atoms. Those atoms follow very specific rules, but describing the outcome is not possible with a simple set of equations. So the social scientists have a much more aggregate approach to try to explain outcomes in society. Give you an example of the type of interaction that happens when you have a group of people and not a group of physical objects. We can think of the Hawthorne experiment. Here you had a factory that was manufacturing telephone parts, and some social scientists came in to study the effects of lighting on worker productivity. And so they increased the amount of light in the factory, and then they interviewed all of the factory workers, and this increased productivity when they measured it. And so they increased the light again, and this further increased productivity. And again, they interviewed the workers to get their reaction, and they said, yeah, it was good that there was more light. And then to finally test the effects of light, they reduced the amount of light, expecting that it would reduce productivity. But what in fact happened was it further increased productivity. What was happening was the process of interviewing the workers was creating a reaction effect. And it was this effect that was increasing productivity and not the light itself. Humans interact with their environment. If you have a rock and you throw it down a hill, it will follow a very set of precise laws and hit trees and other objects on its way down. If you take a human and you throw them off a hill, they're going to try to maneuver themselves to avoid the oncoming trees and rocks, because humans interact with their environment, and they interact socially, psychologically, and politically with other humans. It's this kind of complexity, the complexity of economic relations, political relations, and warfare, that social scientists are equipped to answer. So this brings us to epistemology. In other words, how do you know what you know? And so I'm going to show you how we use the scientific method to create valid information. This is very important because as a social scientist, we're going to come up with conclusions, and then we're going to want to recommend these solutions to problems to political leaders. And the political leaders are going to want to know, why should I believe this data? How do we know this recommendation you're providing is valid? So I'm going to show you how we use the scientific method to create valid information. There are two sources of information. The first is deduction and the second is induction. These are ideal types and they both have a role to play in the scientific approach. So you need to know both of them. Deduction is axiomatic reasoning. It's drawing conclusions from postulates. It uses internal consistency criteria for validation. So it's essentially a logical language. For example, since wars make people suffer, we could deduce that it would be rational for most people to wish to avoid war. This is a prediction. Right? It's entirely logical. Induction is empirical reasoning, where empirical means knowledge obtained through research from nature. So you're drawing conclusions from observed behavior. This uses external consistency criteria for validation. It looks at nature and tries to determine whether this phenomenon is present or not in nature. For example, if we want to know where war is most frequent, we have to go out into nature and make a count. Where are the wars happening? If we could give sort of a personified analogy, deduction is like Plato sitting and coming up with logical deductions, but without ever venturing out into nature. Induction is like Aristotle, who had no preconceived notion of evolution or natural selection, but he made a collection of fetuses, human, from pigs, from birds, from fish, and he noticed that all fetuses were very similar in shape. And he concluded that it's possible that there's a common origin or a common origin of development of all life, though he didn't have a theory that he was testing. He just simply made the observation. Now in political science, we use both deduction and induction. We use deduction when we have difficulty observing nature. We can't easily travel to a hostile capital. For example, visiting the Kremlin in Moscow during the Cold War and finding out what their military policy was. We would be arrested. So we have theories that we apply at a distance. We gather what data we have without going to Moscow and we come up with a conclusion. We use induction when we're not sufficiently confident about our underlying causal logic. We don't know how or why a phenomenon happened. In these instances, we go to the location of the phenomenon and conduct a count or a measurement to find out what happens. In the social sciences, we do both, but we're supposed to be using deduction first, and we'll talk about that later. Here you can see the 1746 Battle of Culloden between the Highlanders against a combination of lowlanders from Scotland and the British Army. Now, a theory is a possible explanation of events, and it has 8 elements. These 8 elements will also be the 8 elements or the 8 parts of your final course paper. The first element of a theory is the research question, or better yet, the puzzle or the problem. A research question could be, why do wars happen? Why do wealthy states lose wars to small, poor countries? But it's much better to have a puzzle. A puzzle is a contradiction between different theories, or a contradiction between a widely believed theory and some cases that turned out or had outcomes that were in the opposite direction of the prediction of that theory. And humans have a natural interest in solving puzzles. And so a puzzle is much more compelling. For example, if all states should prefer to win wars, why did the US pursue policies that brought about defeat in Afghanistan? This is a puzzle. We expected a different outcome. And so coming up with a research question that addresses and solves this puzzle, either by altering the theory or by fitting the theory to the case, is much more satisfying and productive. The second component of a theory and your paper, which this outline is going to guide, is the literature review of the current hypotheses. So what's a hypothesis? It's a statement predicting the relationship between variables, between a cause and an effect, or a cause and an outcome. Now, we can never test a theory. Theories are too large and broad. We break theories down into their component discrete hypotheses, and we test each of the smaller hypotheses. In the course of this course, you're going to come across many theories that'll have sub-hypotheses that are sort of broken away from the theory. So what does the literature review contain? It's not simply a list of books and articles that you read. A literature review is an attack on the current knowledge of the subject. So you want to survey previous hypotheses and explanations and predictions. Right? Explanations are mechanical descriptions of how things work, and predictions are if-then statements. If we see these, then those other things are going to happen. We want to highlight important or crucial cases that remain unexplained. An important case could be the case of, say, World War I. World War I is frequently used as a case of an accidental, unintended, undesirable war, and is used as a model for how a nuclear conflict could break out. Or crucial cases. These are cases that determine the argument one way or the other. Was the Vietnam War shortened by bombing by the US Air Force? Or was it lengthened by bombing by the US Air Force? Right? So we want to highlight the cases that most people in the literature refer to when they're trying to test an argument. We want to identify contradictions or puzzles in the current theories, or cases that are not well explained. We want to highlight the weaknesses of the previous theories. So this is a hatchet job. We're going after other theories and showing their flaws. We want to boldly challenge the conventional wisdom. Don't always assume the most basic things are true. And finally, we want to identify the cases most commonly used to test the current theories, because we're going to need these later on, as I'll show you. The third element of a theory is to list the hypotheses that were discovered while you were looking at the lit review. So here we were looking at the current theories, and there are two aspects of the current theories that we're interested in. We're interested in the predictions and the explanations. A prediction is an if-then statement. If these conditions hold, then that outcome is going to occur. It's important to have predictions for a theory because otherwise we don't know what it's saying. And we want the predictions to be precise and measurable. But predictions are not enough. We also want an explanation. We want to know mechanically how did the cause produce the effect. So it's not enough simply to make a prediction. There's going to be a war, for example, or this battle is going to be won. We want to explain why. It is not enough simply to make a prediction. We have to have both a prediction and an explanation. Now there are two caveats. The first is, do not use a straw man argument. A straw man argument is an argument that is too easily falsified. Probably because it's designed to provide an easy, crucial case. We will talk later about crucial cases. But a straw man argument is an argument that's very easy to falsify. And therefore, it's not a satisfying argument. And it's not an argument that a reasonable person would make. And so it shouldn't be one that is addressed. So if you come across a straw man argument, or a very weak argument, or an easily falsified argument in the literature review, ignore it. An example would be defeat is caused by militarily unprepared states. You know, it's probably true, but it's so obvious. The question here is not why the defeat was caused by a militarily unprepared state. That's fairly obvious. The question is, why was the state unprepared? So here we can replace the straw man argument with a more interesting one, which is, what is the cause of the unpreparation, which in turn caused the defeat? A second caveat is, do not use tautologies. A tautology is a non-falsifiable assertion. Every assertion we make or that we collect has to be falsifiable. In other words, we have to be able to measure it and prove it wrong, show that it's incorrect. An example would be, defeat happens when a stronger state defeats a weaker state. Okay, it sounds fairly obvious, but the problem here is, how do you measure a stronger or a weaker state? You're not supposed to say, well, you know what, the defeat occurred, and therefore the defeated is the weaker and the winner is the stronger. You can't have something true by definition in the sentence. You have to have an independent way of measuring stronger and weaker. You could say that stronger is more soldiers and weaker is less soldiers. So the defeat happens when a state has more soldiers and it defeats a state with less soldiers. That is a better way of formulating that argument. And then it's no longer a tautology. But in its original form, where the definition of stronger and weaker is tied to the event, the outcome, it's a tautology. So never have a tautology. Never have the terms in your prediction depend on the definition. Step 4, to propose improved hypotheses. Now this is where your role comes in. You've done a survey of the shortcomings in the literature, and now you have to fix it. That's the core of your paper. Coming up with a better solution to predict and explain the phenomenon that was previously not well explained. So it's very important that you provide the predictions. What will happen under what circumstances? As well as the explanation, which is, mechanically, how did this come about? Because it's not only about predicting. Political scientists must also have an insight in the mechanics, the many steps between the emergence of an idea that turns into policy, that gets passed into law, that's then implemented as grand strategy. All of those steps have to be identified. Counterintuitive theories and ones that oppose the conventional wisdom are the most interesting. So be bold, challenge the conventional wisdom. However, specify the scope conditions of your hypotheses. I mean, what are the limits of your theory? If you were to have a theory about the role of military government and procurement of equipment, or military government and causes of war, it wouldn't apply very well to a country that doesn't have a military government. So you would specify the scope conditions of a theory of military government. It only applies to countries that have a military government, or who have a significant presence of military people in the government, or a government where the civilians have had prior military experience. All scientific tests are competitions between hypotheses, predictions, and explanations of rival theories. So every paper that's scientific is a boxing match between two or more contradictory predictions and explanations. You might prefer one theory over the other, but your job is to be an impartial referee in the match. It's that impartiality that creates validity of your test. So ultimately, we're aiming at the formulation of a set of generalizable hypotheses. Many students and scholars have a very specific interest or a specific country or region or time that they're interested in. But as social scientists, we're obliged to broaden beyond our one single case area of interest. We want to write for the phenomenon, not the case. So we want our theories to be generalizable to other cases, to other periods in time. So when you design your hypothesis, keep that in mind. Do not refer in your theory ever to a specific case. Keep your generalization abstract. So what's a generalization? It's a covering law that applies to a group of cases, not to a single case. And that's our goal as social scientists. We want to expand our knowledge of theory. Even though as policy specialists, we might want to have a specific focus on a given country or a given case or a given time period, as social scientists, we have to reach beyond that. So your new model that you construct in this section must not refer to the case you're going to test it on. If you want to test it on a particular case, mention that case nowhere in your theory section. Not even briefly, not even once. If you do, you're committing a breach of validity because your favorite case or event is going to inspire your theory that is then going to be tested back on the case. And that is a circular argument, and that makes your scientific approach invalid. So don't do that. Never mention the case when you're developing your theory in section 4 or section 5. And the simple reason is that you can't derive a theory from a case and then test it back on that case. That would be tautological. It would be non-falsifiable. Step 5, the identification of variables and their operationalization. So scientists in the laboratory will use things like weight or mass to attribute measurement to an object. Right? Those are the indicators they use. Economists use amounts of money or inflation rates or levels of unemployment. Domestic political scientists, Canadianists and Americanists, focus on votes or polling numbers. But in international relations and causes of war, we tend to focus on power. This is very hard to measure. Typically, we think of power as a relational type of measure. It's what actor A could get actor B to do when actor B would otherwise not do it. And the likelihood of actor A succeeding is their level of power. So power is not a property. You don't have X amount of power, like X amount of airplanes or X amount of ships. But you have power over something else. And this is very difficult to measure. Now, ultimately, we look for these indicators in a model. Now, a model is a deliberately simplified representation of reality. Okay, it's an operationalization of our theory. Models don't have to be realistic because they're typically outrageous oversimplifications of reality. Life is complex. This lecture right now is influenced by the gravitational pull of Pluto, a small solar object very, very far away, but nevertheless having an effect. But the effect is so marginal that we don't have to highlight it. In fact, there are almost an infinite number of things that are influencing this lecture, the vast majority of which would be too difficult to measure. So a model is much simpler than that. Typically, we have three variables, and these are the variables I would request from your paper. The first variable might explain 20% of the variance between the cause and the effect. The second variable might explain 10 or 15%, and the last variable might explain 5%. All told, the first, second, and third variable together might explain 50% of the outcome. That it would be an incredible finding if you could find three variables that powerful. So, you might recall being in a grade school recreational yard, and you're having a dispute with your friend, and your friend is accusing you of not being realistic in one of your ideas. You can't make that argument with a model. Models are deliberately unrealistic. They're simplifications, oversimplifications of reality, because we cannot comprehend the full complexity of the reality we're looking at, especially in the social sciences, which are so complicated and so reactive. So we call this operationalized theory. When theory has indicators added, and we've added measurements, that becomes operationalized theory. Now ultimately in a model, our dependent variable, or the outcome we're interested in, is the focus of the problem. So you ask yourself, what do you want to explain? Well, how do arms races, for example, relate to war? Right? What we're trying to explain there is war. The happening of war from a state of non-war to a state of war. So that is what we're trying to explain in the model. The dependent variable is typically the effect. Right? We'll talk about that in a few moments. And it depends in turn on the independent variables, which are the cause. So what causes war or peace? Right? And there could be a number of different explanations, which is the purpose of this course. Now ultimately it comes down to what is causation? And this is a huge philosophic debate, which we'll get to next. Here you can see U.S. Sherman tanks deployed in Korea in 1951. So this is some of the notation that you're going to have in a model. And you need to know these. Instead of cause, we say independent variable. Now it's a variable because it's got to vary. The values have to go up and down. It could be a very sunny day, and then it could become a very overcast day. Right? It has to have different values. You could have a high level of inflation in the economy and then a low level of inflation. Now we call the cause an independent variable, abbreviated IV, because it has to be independent from prior causes. Remember, this model is a simplification of reality. We don't want the variable to depend on a previous variable that depends on a previous variable before that. It gets very complicated. You get this infinite recursion problem going back to the beginning of time if there is a beginning to time. So we artificially cut it off from prior events. All right. Now there are, of course, statistical techniques that allow us to go back to previous steps in a process, but here we're going to have a simplified model. So we call the cause the independent variable. Next we have the dependent variable. This is the effect. Again, it's a variable. It has to change values. For example, in this class, the variable we'll most commonly focus on is the variable of war, which implies non-war. Not necessarily peace, but a state other than war. So we have to have that variation. We're not only looking at war in this class, we are also looking at peace, because we cannot explain the occurrence of war if we cannot also explain the occurrence of peace. They vary between each other. So the dependent variable is called dependent because it's dependent on the independent variable, right? It emanates from the independent variable. And we abbreviate the dependent variable as a dv. So what's an intervening variable? An intervening variable is a variable that operates between the independent variable and the dependent variable. The independent variable is the cause, and the dependent variable is the effect. But sometimes there's an intervening variable, abbreviated IVV, which changes the effect of the independent variable on the dependent variable. So here's a historical case. It's a case of the effect of a political system on an economic crisis. following the 1929 stock market crash in the United States, there was a general shuttering down of industrial output across the entire world. This led to mass unemployment in Europe and most countries of the world, but in particular the United States and Germany, which were both heavily industrialized and, in the case of Germany, a large exporter. So you had millions of heads of households out on the street without jobs. Now, you had two political systems. In the US, you had a first past the post system where, in a particular district, the winner politically was one who had the largest plurality, or the largest single group of voters in that district. And they didn't have to be the majority. You just had to have the most votes. In Germany, you had a party list system where the proportion of votes in the total society was then distributed according to the number of votes to each party. And the parties would post lists of their candidates, and as many votes as were gotten would then be translated into the top names on that list, and those would be the representatives in government. Now, the unemployment triggered both left-wing and right-wing reactions. You had both right-wing fascist political parties in both the US and Germany, as well as socialist and communist movements. Now, in the US, in a first-past-the-post system, the dynamic of the process is that in order to get elected, you had to appeal to the largest group of voters in your district. So you typically wouldn't appeal to the communists or to the fascists that would be on the extremes of the political spectrum. You would target the middle. And so there was a moderating effect in the US. The result was the election of a Democrat president, Franklin Delano Roosevelt, who implemented policies that led to gradual reemployment through public projects. In Weimar Germany, in contrast, political parties got representation. So on the one hand, you had the socialists and the communists, as well on the right, the NSDAP, National Socialist Deutschland Allbetung Party, later the Nazi Party. And so the Nazi Party was able to get representation in Germany in a way that didn't occur in the US. So here you have the same independent variable, an economic crisis leading to unemployment, leading to radical politics. But the intervening variable was different. You had a party list system through proportional representation in Germany, and you had a first-past-the-post system in the US, leading to very different political representational outcomes. In the US, you had moderate foreign policy. In Germany, with the arrival of Nazis in power, you had an aggressive foreign policy focused on war. And so two very different outcomes from the same effect because of the intervening variable. Now, ultimately, we're looking for a correlation between the dependent variable and the independent variable, meaning as change of values occur in the independent variable, the dependent variable would also change values. And as I mentioned before, the dependent variable is what you want to explain, right? We want to explain war and peace in this class, and so that's what the dependent variable is going to be, right? Ultimately, we're trying to explain variance in the model, how changes in values in the independent variable causes changes of values in the dependent variable. And we want to show that as the independent value rises or drops, so does the dv value follow with it. Now, there's a question of direction. When we say there's a positive relationship between an IV and a dv, we mean they go up together, but they also go down together. For example, if I get more customers, then I'm going to make more money, right? But if I get less customers, I make less money. That's still a positive relationship because the IV and the dv are going up and down together. Now, a negative relationship is an inverse relationship, meaning the more of the independent variable I get, the less of the dependent variable I get. For example, the wealthier a country is, the less likely it is to go to war, right? But we can also reverse that inverseness, which is as less money is made available to that society, so the probability of war goes up. Okay? And we can always redefine variables to change them from a negative relationship to a positive relationship. Instead of saying the country gets richer, we can say the country's getting less poor, right? And reverse the value. So this is a depiction of a model for war. Now, of course, we spoke about this before. It's a misnomer. War here is really war/peace, right? We're trying to explain both. We explain peace when there's no war, and we explain war when there's no peace. All dependent variables have to have at least two separate values. Now, in this particular model, we can see there's IV1, which is state A and B buy weapons. This is a model for an arms race. And you can see the plus that links IV1 to the DV. So the more aggressive the purchases of weapons, the more likelihood that war is going to happen. We can see IV2, the level of hostility, has a positive relationship on the incidence of a dispute, which is in this case an IVV, an intervening variable. And the more disputes there are, the more likelihood there's going to be a war. So this is just a model. I haven't tested it. I don't know if it's correct. It's reasonably intuitive. Most people think of arms races in this way. And notice how there are two separate causes here, two separate independent variables. Now, we need to know these two terms because they occur a lot in the literature. And there are two types of causes. They're ideal, which means we speak about them, but they almost never exist in the social sciences. But you should be familiar with what they mean. The first is a necessary cause. This is a required event, something without which the outcome could not occur. The dependent variable could not vary to a particular value. For example, you have to have weapons to have a war, right? Now, we know this is not true. At least in the intra-state conflict, or the interstate invasion by a non-state actor into Rwanda in 1993 that led to large-scale genocide. The genocide was conducted with household implements, farming implements. There were almost no firearms used in the genocide. So weapons can be fashioned out of almost anything, which means you don't need weapons to have war. Now, you can always have a trivial necessary cause. Like you can't have a war without oxygen. Obviously, because people can't breathe and the combustion effect of certain weapons wouldn't work. But that's trivial because the frequency with which you have no oxygen is very limited. And if you were to go to a place where there's no oxygen, such as fighting in space, you have weapons that are adapted to not requiring oxygen. So it's a trivial cause. In other words, it's not useful to know that necessary cause. A second type of cause is a sufficient cause. This is modeled by an if-then statement. If this cause is observed, the effect will invariably follow. So, if there's a revolution, a war will follow. This is a very commonly held belief in the social sciences. There's a revolution in France in 1789, in Iran, 1978, 1979, in communist China. And shortly thereafter, the country was involved in a war. Okay, so we see sort of an inevitability here. If a certain event occurs, a single cause, then the effect will inevitably follow. And other ones are, for example, if a leader seeks a war will happen. That one's almost, again, trivial and non-falsifiable. In reality, necessary and sufficient causes in the social sciences almost never occur. At least I've never found one. Here you can see a Soviet BMP armored infantry fighting vehicles being lined up during an exercise. Now, sometimes there are curvilinear relationships. In fact, most of the time there are curvilinear relationships. And the way that we describe relationships qualitatively and in statistics generally are linear because of limits of our mathematics and limits in the complexity of describing complicated waveforms. So here I have almost a silly example of your paper writing for me. If you were to immediately embark on writing a paper for me now after class, the paper won't be very good because you won't be at all stressed by the impending deadline or frankly by me about to read it. So it'll be a poor quality paper. If, on the other hand, you were to write the paper the day before it was due, you would be shocked into neural paralysis and will have no good ideas, and the paper will be dreadful and poorly written and badly edited. So ideally, you want to write the paper probably several weeks before the paper is due, when there's sufficient stress to give you that little spice to make the paper a sharp one, and one that I'd be looking forward to read. Most relationships in the social sciences are curvilinear. Too much of something, and then you're going to have a metabolic collapse or a sudden shift in the relationship. So you can certainly recognize there's a curvilinear relationship in your paper. You know, the more wealthy a country becomes, it doesn't necessarily become more pacific. It might end up being so powerful and so wealthy, it's no longer sensitive to the interests of its poorer neighbors, and then easily embarks on conflict. Right? We can imagine that type of event happening. Now, there's a couple of issues that almost a checklist that you need to go through when you're writing on your model, okay, and things you don't want to be doing. Number one, do not select on the dependent variable. This is a very serious dysfunction. What is this course about? It's about war? No, it's not about war. This course is about war and peace. We are not studying constants. For example, you look at the Earth and the shape of the Earth and its impact on weather. The Earth is round. The Earth is always round. So the fact that the Earth is always round can't explain change in weather, because something that doesn't change, the shape of the Earth, can't explain or predict something that changes all the time, like the weather. So it's clearly not the Earth's shape. It's the Earth's location in the solar system, its rotation, its inclination, the rotation of the oceans on the shape of the Earth, caused by the rotation of the Earth at its inclination around the sun, and the role of the moon. Very complex, but the shape of the Earth itself is a constant. So whenever you're stating that you're studying something, you have to identify both of the values. Let me give you an example of a fallacy or dysfunction that results from selecting on the dependent variable. It was once thought that the goal should be for militaries to win. So someone studied militaries' victories in the 19th century, and they noticed in the victories that almost always the country that won wore red. This is obviously the British building their empire in the 19th century and frequently winning their battles. And the conclusion is therefore, well, if the country that wins all the time is wearing red, countries should equip their soldiery with red uniforms. But of course, this is invalid, and it's so obviously illogical, because the scholar forgot to count the defeats, such as Isandlwana, where the Zulu destroyed the British army, or where the East India Company British army was defeated in Afghanistan in 1839. If you also count the defeats, you're going to notice that there were plenty of defeats where soldiers wearing red were overrun. So you have to look at both categories. You cannot focus on a single category, or you're going to come up with very silly and erroneous conclusions. And we want to avoid bias, and so that's why we have to look at both categories of the dependent variable. Now, a second issue is more cautionary. Most political scientists look at events that are non-events, right? Wars are actually quite rare. Now, you know, at any one time in the world, the 200 plus countries, some of them are involved in a war. But if you were actually to map out every country, all the years that it's been in existence for any given century, and you do that for all the countries, and then you count how many years of war there are for each country, you'll find that countries are at war less than 1% of the time collectively. War is actually very rare. Most of the times, states threaten each other. They're not actually at war, but they're preparing for war. But we don't know what they're thinking. During the Cold War, for example, the Soviet Union and the United States never attacked each other. But it didn't mean they didn't plan to attack each other. So, why did the Soviet Union not invade Western Europe between 1945 and 1991? Was it because they didn't want to? Because the Soviet Union was deployed defensively? Was it because they created the Warsaw Pact because they didn't want to get reinvaded by the Swedes, which the Russians fended off at Poltava, or get it invaded by the Napoleonic French, or the Wilhelmine Germans, or the Nazis? Or did the Soviets plan an attack every single night and simply conclude that NATO was too strong? So you have these two choices. Now, I have no solution here, except that a political scientist, a social scientist, has to focus on the likely behavior of the decision maker. Typically, leaders anticipate reactions. Leaders just don't wake up and go, hey, let's have a war today. Leaders wake up and go, if I do this, if I move a chess piece on the board, what will my opponent do? If I embargo this country, if I build more missiles, if I open up a dialogue, if I engage in cultural exchange, if I deploy my fleet off their coast, what will they do? And you anticipate what the other person's going to do. And they're anticipating what you're doing. And so you've got a complex process of anticipation. This is how leaders think and strategize and speculate about the consequences of their actions. So most events are a form of non-event, things that we cannot observe because most of the planning is going on inside the minds secretly of these leaders. And so we have to be aware of this as social scientists, that most of the things we're counting are difficult to count. I have no immediate, obvious solution to this problem. It's a methodological problem all social scientists face. A third issue are counterfactuals. Counterfactuals is a form of alternate history, things that never happened. Now, why would we deal in make-believe counterfactuals? Well, we've only had one nuclear war. At the end of World War II, the US dropped 2 nuclear weapons on Japan. Nuclear weapons are hugely important. They have restructured international security and international relations for more than half a century. We need to be able to study them and study their consequences. And because we have so few cases, in fact we have one case, although there are some analogy type cases we can use, we're forced to use counterfactuals. So counterfactuals are events that did not occur, but they could have occurred. An important consideration when we have counterfactuals is that they have to be plausible. They're things that could have reasonably happened. We're not going to have time travel. I don't think it's plausible that aliens are going to land anytime soon and alter our international relations or the idea that they're here already. So our assumptions have to be co-tenable with reality. So let me raise a profound question. What if Adolf Hitler was killed accidentally, perhaps in an auto accident in the 1930s? What would have happened to German foreign policy? Would World War II have happened? This is an important question. It tells us about the relationship between a leader and their ideology and their political party and their followers. It tells us about other actors in Nazi Germany that also wanted war or didn't want war. It tells us about the role of deterrence and how the other countries could have stood up more strongly and stopped Germany. So there's a lot of information in that assumption. Is it plausible that Hitler could have been killed by an auto accident? Certainly. People have been run over, although not political leaders on that level. So counterfactuals are valuable for asking those kinds of questions. If you're going to have an operation to assassinate political leaders, you will want to have a theory about counterfactual effects about killing leaders. But is it cotenable with reality? Cotenability is an aspect of plausibility. Is this a likely outcome within the reality? A big example is World War I. Some people ask, would World War I have happened if the French and the Germans didn't create these very rapid train timetable movements where millions of soldiers were mobilized within a week to 10 days, deployed on each other's borders, and then you had a use it or lose it dilemma where if you didn't deploy the soldiers, then then your economy would crash because your factories were empty and there was no one to collect your harvest. So was the timetable setup of the mobilization of the respective armies leading up to World War I, is it plausible and co-tenable with reality that they could have canceled that whole timetable process and then avoided World War I? Well, some authors have argued, you know what, that's not co-tenable with reality because France didn't deploy the army quickly for cost. The French deployed their army quickly because they needed to get to Germany before the Germans mobilized and destroyed France's ally, Russia. So it wasn't done simply to get the soldiers to the border. It was done to show the French had commitment to save their Russian ally. So even if there was no trains available, the French would have found another way to rapidly come to the aid of their ally. So that counterfactual of making the timetable mobilization replaced or canceled is just, it's not tenable with reality. Now, you cannot use counterfactuals in your papers. All right, you have to use real historical cases. I don't care from what century or from what region, because this course covers war in all its aspects from the beginning of time, although most of the theories we'll be looking at will be recent cases. But you could use counterfactuals to confirm your theory. At the end of your paper, you could ask, if this independent variable didn't go this way, if Hitler had been assassinated, if train technology did not exist, what would have the effect been on the dependent variable? Would war have occurred? So you could use it as a check at the end of your paper to speculate briefly in a concluding paragraph how history could have turned out differently. And this is an interesting exercise because it shows our depth and our understanding of particular independent variables. Next is we want to avoid constants. Right? We spoke about this before. You can't predict outcomes using a constant. And one of the most common constants is human nature. This is problematic because if humans are peace prone, we would expect peace to occur all the time. If humans are war prone, then we would expect war to occur all the time. So human nature can't be a constant. Maybe personalities vary, but if personalities vary, then there is no one human nature. So in your paper, please avoid references, unless it's very sophisticated and it's well developed probabilistically, a theory as a cause of war that comes from human nature. And the last point is theory precedes observation. You might recall we were talking about deduction, which is logical creation of theory, and induction, which is measurement in nature. And I said that in the social sciences we very often mix both, because people are inspired by an image that goes on to a theory that becomes a story, that becomes a more elaborate set of hypotheses that then develops into a great historical analysis. But we have to start somewhere. And so I ask you to look at your ceiling and tell me what color you see. Right? Tell me about the nature of the color of the ceiling that you're looking at. What color is it? What is the fact? Well, logically, as you're staring at the ceiling, you should know that color does not exist. It is a creation of your mind to explain the frequency of light waves transmitted by your eye and received by your brain. Green, white, gray, black, red, they don't exist. Color, as a fact, is a creation of the mechanism of your mind, of the theory of your mind. So theory always comes before observation because facts are not real. Theory defines what the facts are. There is no color. So in your model, you're going to secretly use an interactiveness between deduction and induction and deduction and induction. But when you write your paper, you must be strictly deductive. You start your paper with an abstract theory. You do not refer to your case. You do not let the reader know that your theory was inspired by a case, even if it is. Because to be methodologically valid and sound, you must preserve the abstractness of theory. Because if your theory refers to a case, it's tautological, it's non-falsifiable, it's circular, and it's wrong. And the consumers of your research will lose confidence because you've broken that fundamental rule. So theory always precedes observation. Here you can see Portuguese soldiers involved in a suppression of an independence movement in Mozambique in the early 1970s. Step number 6, test design. So we have competing explanations, right, which we developed by doing our literature review, and we proposed a better explanation of the phenomenon with our own theory. So we've got these two rival theories. So what's a competing explanation? Well, they're rival explanations or rival hypotheses. Now, in the test design, hypotheses must either be falsified or put into competition with one another to see which provides the best prediction and explanation. What we're trying to do is establish correlation. Right? We're trying to show as one changes value, it has an effect that changes the value of the outcome. Right? This is not the same thing as causation. Correlation is sort of an association of movements between the independent variables' values. Causation is showing that one thing causes another. Explanation is how we show causation. Prediction is how we show correlation. Okay? Here you can see a section, or rather a detachment of Soviet infantry having dismounted from a BMP. So let me ask you a question. Can you prove any cause-effect relationship to me? Let's take, for example, gravity. Right? Imagine I'm holding a pencil, and you could pick up a pencil right now. Is there any logical reason in which you can prove that the pencil will fall when you let go? All right, you might even just let go of it right now and say, well, there we go. I've just proven that the pen is going to fall when I let go. But you know what? You could drop it a second time, a third time, and a fourth time. But the millionth time you drop it, it won't fall. Right? That's always a possibility. And because of that possibility, dropping the pen in order to prove the pen will fall is not a valid test. Repeating an experiment that can be canceled any time to generate a law undermines the law. So dropping the pen doesn't prove anything. So we have to come up with something deductive, not inductive, something logical. Let's think about it. Is there anything from philosophy that we can draw on? No, you know what? I know it sounds crazy, but you can't. There is nothing you could say, no logical argument you could make that will show that the pen will fall when you let go. All right, this is horribly tragic because you've paid so much money to come to Concordia to collect knowledge, and here I am telling you that nothing can be proven. Not in the political science course on a causes of war, not in a chemistry course, not in a physics course, not even in a philosophy course on logic. There is absolutely no proof anywhere in the universe, right? Even if you were to build a time machine and go back in time and survey every event involving gravity, and you were to go into the future using a time machine, and you were to stay in the present and visit every inhabited planet to conduct your test, it would still prove nothing because one instance will cancel the law. So there's no proof. You might as well just pack your bags and go home, right? Because all knowledge we have now is basically false because we can prove nothing. Okay? But there's a solution. We can't prove anything, but we can disprove. So there are two solutions to the problem of not being able to prove anything. And the first comes from Ernst Mach, a physicist, who argued, well, you can't prove anything, but you can disprove. This is the criterion of falsification. So you cannot prove a theory to be correct, but you can disprove a theory to be incorrect. Now there are some probabilistic solutions to this. When you do statistics, you're going to notice that there's always a null hypothesis. The null hypothesis is the standard hypothesis, and it says there's no relationship. And so what you're trying to do in statistics is falsify the non-relationship. You're trying to falsify the null hypothesis. And by successfully falsifying the null hypothesis, you're then left with the hypothesis that shows a relationship. Sounds a little bit technical, a little bit confusing, but you'll learn that as you repeatedly apply significance tests. Qualitatively, we have the same issue. We can't prove something, but we can disprove a relationship. So you're going to take a theory, break it down into discrete hypotheses with indicators, and try to disprove those. So remember that pen that you're holding in your hand that you're going to drop to prove gravity? Well, we can't prove the existence of gravity because that test can fail now or some indeterminate time in the future. But we could come up with a hypothesis that says there is no gravity. When you drop that pen, it falsifies the hypothesis that there is no gravity. That is how we structure our papers. Every hypothesis has to be redesigned so that we have something to falsify. That is how we create knowledge. Now, in reality, in terms of human nature, our brains are designed to create contingent laws. For example, when you woke up this morning and you went out and did your chores, you certainly weren't concerned that gravity is going to be canceled at any moment and that you're going to be flung into space off the surface of the earth. You weren't holding onto the furniture or to the bushes outside of your house while you're putting out the garbage, because your brain is designed to recognize patterns and then to turn those patterns into laws. But the standards of knowledge that we use for a scientific report is much higher than the intuitive laws that we build our lives around. So that's why we have to be explicitly clear when applying the falsification criterion to hypotheses. So we could come up with a hypothesis from a theory that, for example, wars are caused by rapidly escalating our arms races. And so we do a study, and we look at a whole bunch of arms races that were rapidly escalating, and we find that there's in fact no link between a rapid escalation and the result of war. And so the hypothesis is then falsified. So there's really two approaches to falsification. The first method is it could be we could have a hypothesis that's falsified by the available data. Right? We expect there to be a relationship between rapid arms buildups in war, and we find in fact there's no relationship at all, and so we falsify the assertion of the link between a rapid buildup of arms and the outcome of war. Another solution is we have the availability of an alternative theory. Now here in the picture you can see a Nigerian government soldier during the Biafra War of 1969, and you can see a Canadian Leopard bridge layer deploying its bridge. So the second criteria is the competing criterion. Here, a theory is good if, one, it can explain and predict the phenomenon, and two, it explains more than the previous theory or alternative theories. Now you guys might recall at the very beginning of this discussion, you had to do a literature review. In the lit review, you had to identify some hypotheses and predictions. And then you examined the mistakes and the shortcomings and the errors in those predictions, and you came up with your own better predictions. So you see, what we've created is an opposed boxing match. We have the conventional wisdom hypotheses, and we have your new hypotheses, and you are the referee judging to a test which is the better theory. So this is where the competing criterion comes in. It's better than the falsification criterion, because instead of having a theory set up against the data, here we have two theories set up against each other. And this is why we do a lit review, because it's from the lit review that we identify what the conventional wisdom is. It's where we get our first set of hypotheses. And then we have to come up with our own theory. That's where we get the second set of hypotheses. So every scientific paper is going to be a competition between two separate theories, and your job as referee is to make sure the methodology is good so that we get valid results. So let's apply this. Let's think of theory one argues that wars are caused by arms manufacturers, right? And we go out and we study it. We find that 60% of wars do have arms dealers that are heavily involved, right? And in 40% of cases, wars happen for other reasons. And then we have a second theory that wars are caused by alliances. And we see that alliance patterns play a role in 90% of wars that occur, and only in 10% were wars caused by other causes. So it seems that alliances explain more and predict more than arms manufacturing. So the theory of alliances is a better theory according to the competing criterion. It explains more. Here you can see a German Leopard 2 tank. Now, a major challenge at all times is the problem of pari passu, or other things being equal in Latin. And what that means is, how do you control for all of the other multitude of causes? Remember, reality is very complex, especially in the process of war. You know, what caused the war? Was it the type of regime? Was it the thinking inside the leader's head? Was it the influence of the military leaders, the media? Was there a popular mood for war? Were there alliance or geographic or geopolitical or resource or infrastructural imperatives? Great level of complexity. For us to identify a cause, we need to know that the other causes are not important. Okay, we call this the ceteris paribus, right? Where we want to control for the effects of all the other things, keep other things equal. Right? So we want to be able to measure the effect of a cause while controlling for all of the other causes. Ideally, you want the number of cases necessary to demonstrate the variation in your dependent variable. So if you have a variation between cause, between wars and peace, you want to have independent variables. Some might draw from the alliance causes, some might draw from the type of regime type causes, right? So we want to be able to isolate all the different causes. This is why we have at least two competing explanations. At least we'll have two separate sets or two individual independent variables competing against each other. We could also take a look at a case across time, say France throughout the 18th century. This is called a longitudinal case study because it's longitudinal across time. It's a study of a country across time. In that time period, France was sometimes at war and sometimes at peace. And we would look at the causes to see which predicted the change of behavior across time. We could also look at two separate cases, right? And we could compare the two different cases and control for different variables between the two cases. Either the cases are the same or they'd be different, right? There's no question that controlling for other causes is very, very complex and very complicated. And quantitative approaches tend to do this more easily than qualitative approaches. But controlling for other variables is just as important in qualitative research as it is in statistical analysis. So, if you recall the model that we explored before, here you can see an arms race model where the independent variable 1 has state A and B buying weapons that influence the likelihood of war and peace. We have the second independent variable, which is hostility, which influences the occurrence of a dispute. You can imagine the intervening variable of dispute being a dispute that's a maritime dispute in the South China Sea between China and the littoral states of Vietnam, Malaysia, and the Philippines. Or it could be a terrestrial dispute on a border between, say, the Soviet Union and China in 1969, opposite the city of Khabarovsk, and raises the question of whether maritime or terrestrial disputes are more prone to escalation of conflict. Now, when we're trying to control for other causes, it very often involves us reconceptualizing the causes that we have before us. Is there something wrong with the model? And I think some of you probably intuitively have that sense that, you know what? Weapons don't cause war. Weapons are very expensive. And to convince taxpayers in a democratic country or resource creators in a non-democratic country, to convince them to hand over so much of their wealth and treasure to spend on very expensive weapons is difficult. You need a justification for it. So when people buy weapons, it's normally not in a vacuum. They're doing it because they feel a need for a weapon, probably because the state feels insecure or the state feels it's entitled to conquer something and therefore it wants to build the weapons. So weapons don't build themselves, and weapons therefore can't cause war. So this is a better conceptualization of the arms race model. Here we can see that weapons don't cause war. Rather, weapons are an intervening variable between hostility and war. Countries that are hostile towards each other, for whatever reason, will purchase weapons. And the weapons may make war more likely. We have a whole lecture on the relationship between weapons and war. But weapons themselves are not the starting point. They're an intervening variable. So the terms we use here are that the purchase of weapons by state A and B is a spurious relationship, meaning it's not a real relationship. The real relationship is hostility to war with state A and B buying weapons as their intervening variable. So here we have what would be called the endogeneity problem. The endogeneity problem is when we have a cause that's embedded within the case, and it's not always easy to see. Here, the true source of the conflict, the true intervening variable, is hostility. It's not state A and B buying weapons, right? So we have causation within the model, and it's not true that it's coming from what we originally attributed to be the independent variable 1, right? So endogeneity is when a cause is also an outcome of the process being examined. For example, arms races may be a cause of war, but they may also be the result of interstate hostility. So let's see different ways of controlling for other variables in a much more precise fashion. Most of the research on controlling for other causes comes from John Stuart Mill's logical methodology and is the basis for what we use in the comparative method. Right? I'm going to go through the basic logic of his applications. So the first here is the method of difference. Right? It consists of selecting circumstantially similar cases in many different ways. Right? Read, when I say different ways, I mean different variables. And then comparing the application of the cause in one case with the absence of the cause in the second case. Okay? This is also called similar case design or similar systems design. So here we have two students, student A and student B. Or it could be student A at time 1 and then student A at a later time, right? The longitudinal analysis across time. So student A and student B have the same family structure. That variable is the same. Student A and student B have the same amount of money. That value is the same. Student A and B, however, vary differently on the variable of how much they studied. Student A studied a lot. Student B was distracted and studied less. And then you have the outcome. For student A, it's an A+, and student B, it's a B+. So you control for the variables of family and money, so you can focus on the variable that matters. Now, what would be the application of this in a causes of war case? Well, if you wanted to look at the role of military governments, you could choose two cases in which you had one state with a military government and one state without a military government, but in every other way, the states could be similar. Say, for example, Israel and Pakistan. Both countries have faced adversaries that significantly outnumber them. Both countries at times in their history have had weak external allies. But you can examine under what circumstances the countries went to war, because in one you had a democracy, although quite heavily militarized in Tel Aviv, and in the other country you had a militarized government in different times of their history. with the actual military governing the country for periods of time. And you could then compare the outcome under certain crises to see whether they escalated a conflict. In the picture you can see a Viet Cong resting. Here in another application of the method of difference, and this refers to the article by Edmund Beard in your reader, we have two communities, Aboriginals and Inuit, and we want to find out what explains their variation in their behavior towards war. We look at the variable of land and they're similar. We look at the variable of structure and they're similar. It's not a major incentive. However, we look at ideas and we see that the Aboriginals have a developed notion of conflict where the Inuit don't. And this hypothetically explains variations in the outcome, in the dependent variable of war. So here we've isolated two independent variables, and we have two cases here that are similar in every way except for the key independent variable that explains the outcome. Again, you can apply this longitudinally across time. So we could learn if there is learning happening within a community by looking at the community, in this case Inuit, at time 0, and then looking at their new behavior at time +1 at some later moment. And we see there's change in the variable of ideas that results in a change in the values of the outcome. So if you were to look at France in the 18th century and examine over time their behavior, this would be one of the techniques that you could apply. John Stuart Mills also has a method of agreement. This is the most different case design. So you've got different cases, but they're all similar in producing the same value on the outcome, which in this case is war rather than peace. You can see in the inset picture a monkey about to hit a man with a stick. So it's not true that only humans use instruments to inflict hurt. So here you can see the case of humans who are drawn by gold. They don't have tools and they aggregate in large groups. Chimps have no interest in gold, lots of tools, and they aggregate in large groups. Bongos have neither gold nor tools, and they aggregate in large groups. Dogs love gold and they like tools, and they aggregate in large groups. So in this hypothetical example, you can see that the large groupness is the crucial variable that creates the outcome of war. Here again, we can apply the method of agreement, the most different case design between student A and student B. They have different family backgrounds. They have different wealth levels. But because they both studied, they both had a similar outcome in terms of good performance at school. So you could use these types of structures to control for variables when you select your cases. And the more competing crucial variables you can control for, the more likely you're to increase confidence in the variable of interest that you want to show has a relationship. Here you can see a Soviet soldier with an SA-7 surface-to-air missile. Part 7, the case selection. This is where we test the theory or theories on the data. This is a very important section. This is where most of the disputes occur at my level. Did the researcher choose the right case to make a valid test of their argument? There are two kinds of cases. There are easy cases, and then there are hard or crucial cases. The hard case is the most likely case for the original explanation. Okay, I'll explain what that means. So you have your theory. How are you going to test your theory? You could try and test it against every case in the universe. You could go back in time, you could go into the future, you could examine every inhabited system. The problem is, it's very costly. You're never going to be able to achieve it. Because of the extreme limitations in our resources, what we have to do is strategically select a case or a few cases that we test on that allows us to learn enough to make valid, conclusions from our study. So there are two basic strategies. There are easy cases and there are hard, or also known as crucial cases. So what's an easy case? These are cases that are easily demonstrating your relationship. We would want to use an easy case to highlight a model when it's hard to see the precise relationships. For example, if we wanted to get a close-up view of the impact of an economic depression on creating radical political outcomes, we could focus on Germany in the 1930s. We're going to find exactly what we're looking for. It's going to be easy to make the links between the independent variable of the crashing economy and the dependent variable of an extreme militaristic foreign policy. Here you can see US soldiers fighting in Vietnam. A second type of case selection strategy is the hard case or the crucial case. Let me begin with an example. Let's say you're an ice cream manufacturer and you wish to maximize ice cream sales, but you had a limited testing budget for marketing. Would you test your ice cream on people who like ice cream or people who are indifferent to ice cream? Of course, we will not test ice cream on people who are allergic or who dislike it. They will never buy ice cream. If we test it on people that like ice cream, we're going to basically confirm that there are people who like ice cream and that those people will probably buy ice cream. But we knew this already. If you test ice cream on people who are indifferent and those people indicate an interest in ice cream, then suddenly we've discovered something very valuable. We've suddenly learned where and to what extent we can alter the flavor of ice cream to make it sellable to this new market segment. Case selection strategies are the same for hard cases. We want to test our theory on a case where our theory is going to have a difficult time, where it's not obvious that our theory is going to work automatically or immediately. Why would we want to do this? Because when we are the referee in a boxing match between different theories, we want to give the advantage to the conventional wisdom, to the mainstream ideas, to the original set of hypotheses. Because if our theory can do better than the conventional wisdom while trying to predict an outcome in the favorite case of the conventional wisdom, of the original mainstream set of ideas, then our theory is not only strong, but it's even stronger. It builds up even more confidence. So we're tilting towards giving the advantage to the mainstream conventional wisdom by, where do we get the hard case? By taking the favorite case, the favorite easy case of the conventional wisdom. Remember the lit review that we did at the beginning? This is where we get our hard case. We go to the lit review, we read all the conventional mainstream ideas, we choose the case they use the most often. That's their easy case. Because if we can show that our theory predicts and explains better than their theories on their favorite case, then we create enormous credibility for our theory. So the logic of a crucial case study is to take an important case that is the favorite case of the conventional wisdom, their easy case, the case where their theories are most likely to work, and to test our theory against their easy case. That becomes our hard case. That's why the literature review is so important. Not only are we collecting mainstream hypotheses, we're also creating the conditions for a test by knowing where to test. What case do we choose? So we choose the crucial case from the easy case of the conventional wisdom in the literature review. I cannot emphasize enough how important this step is. In the photograph, you see the U.S. aircraft carrier Ranger during the Vietnam War. Case selection. Case selection is never easy, and these are additional considerations that should be thought of when you're doing your case selection. These are not easy solutions. What you want to do is to demonstrate a causal relationship by falsifying all of the competing alternatives, all the other explanations. Now, this is a problem because if we don't falsify all the other explanations, we could have what's called the overdetermination problem. If someone crosses the street and they get run over by a car, and at the same time they get shot by a bullet, what killed them? Getting run over by a car or getting shot? Wars have many complicated causes, as you will see when we look at the First World War in a future lecture. There are 10 causes. If we falsify 6 of them, we're still left with 4, and we still have to disentangle the complex spaghetti of these different causes. Which one explains the most? Which one explains the least? How do they interact? Is one of them an intervening variable rather than a true cause? This is complicated. Now, there's different ways we can do this. We could use variance analysis. Here we're looking at correlation. We're trying to show the timing of the change in the independent variable somehow is associated with the change in the values of the dependent variable at the same time. But there's always lags. The stock market crash occurred in 1929. The Nazis get into power with Hitler as chancellor in 1934. War occurs in 1939, 10 years later. So you have this expectation that things take time because the processes are not always visible. The overdetermination problem is also called the multifinality problem. When we have too many causes predicting the same outcome, it becomes difficult to disentangle them and distinguish them. Another process is to compare explanations in their mechanism. This is called process tracing, and it comes from anthropology. Here you focus in and you follow a decision, and you trace it from person to person, from institution to institution. It enters the public domain and media as it evolves and transforms, and then ultimately ends up as a decision by the elite decision makers in society. Ultimately, we want each independent variable to be individually falsified, and we want one or at least a few that remain to then be disentangleable. This is not an easy problem to solve. Part 8. The evaluation of findings and the policy prescription. Political science has a goal. People don't do it in a vacuum. It's expensive. Governments and agencies pay for reports because they think it'll help them make better decisions, that it'll be in the public interest. However, you cannot allow your goal to bias your study. You must be strictly neutral when you design your analysis because you're trying to create valid conclusions for decision makers. In your project, in the conclusion, you want to evaluate the predictive and explanatory power of your resulting test. And then, most importantly in the real world, you want to recommend subsequent research. How else do we push the research limits? And then you want to translate that into actionable policy recommendations. Political leaders are not academics. They need you to translate your findings, whether they're qualitative or statistical, into language they can use in politics or in policy formation in the bureaucracy. They don't have the expertise to analyze 20 variables. So you have to simplify it. You have to boil it down to the essentials that they can use to change tangible decisions made by the state. Now, in your course, I actually don't care what your goals are. You have complete anonymity. I will never share your study with anyone. And as far as you and I are concerned, I will happily erase any paper you've written for me when you've concluded the course. But in the real world, where I have been paid to do research, sometimes there are real consequences. If you take a position against your employer, they will terminate your contract, and they will cut your funding. And this has happened to me. So in the real world, policy recommendations are very important. Academically, they're not so important. But I want you to balance it when you write your paper as if the study you were creating had a real impact. So here's a summary set of ideas on what is a good theory. You want your theory to have leverage. You want to explain as much as possible. Get away from only explaining one case, even if that case is an enormous anomaly. You're a social scientist. You have to reach beyond your favorite cases and connect with other social scientists and explain broader phenomena, while at the same time developing your in-depth knowledge of your particular case of interest. You want your theory to be parsimonious. Keep the theory simple. Do not have more than 3 independent variables in your qualitative model or your quantitative model. Why? Because people can't absorb more than 3 independent variables. Decision makers can't. It's far too complex for them. And if you think about it, the first independent variable will explain 30%, maybe 20%. The second one will explain 15%. The third one will explain 5%. You'll never explain more than 50% of variance using 3 independent variables. They drop off pretty quickly. Number 3, you want your model to be explicitly falsifiable. I know it sounds ridiculous, but the best papers are ones which start out by saying in the very introduction, "To prove me wrong, find this." That kind of statement creates enormous confidence in a paper. Hiding your paper behind big words and literary flourish and poetic descriptions is not honest scientific work. You want to be as explicit as possible, in their face as possible, to make as simply crystal clear how to see if they're wrong. Now, you also want to come up with useful generalizations. You want to contribute to the general field and not come up with very narrow predictions and explanations for the phenomenon that you're focusing on. You want your test to be reproducible. If you get run over, anyone should be able to pick up your research project, continue it, and probably reproduce almost the same results if they're using the same case study. And finally, there can be some heuristic value to a research project. You could set up a test in which you think you're going to fail, in which you think your new theories are going to flop, and that it's perfectly acceptable. You are not graded on the success of your theory. You are graded on the validity of you being an impartial referee in constructing a methodologically sound, positive test of your theories on a crucial case. That is how you are graded. It would actually make a lot of sense to test some of the crazy ideas coming out of politicians today, because they believe the ideas, their followers believe the ideas, you may not. So it's perfectly valid and logical to test their theories, even if you have a very strong inkling that their theories are going to fail. This picture here is of an American tank in Vietnam. Now, a note on stochastics. What the hell are stochastics? Stochastics is the probability distribution of probabilities. All observable behavior in nature can be approximated by a normal bell curve. All right, sounds almost peculiar, but you can actually reproduce this yourself. If you were to take a small container, and I would do this if I had a classroom, and in that container you would have 4 numbers, little pieces of paper with 4 numbers on it, 1, 2, 3, and 4. And then you'd pass it around and ask each student in a class to take out 4 of those little pieces of paper. You could, from a large container of those different 4 numbers, you could pick out 4 fours. That would be 16. You could also pick out 4 ones, which would add up to 4, or any number in between. So you could have a number that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, or 16. If you were to ask each student to add up those numbers, and then you were to, on the board, aggregate the numbers together, where every time a student said a 4, you'd put a square on top of the 4, and whenever a student said 11, you put a square on top of the 11. And then you piled up those squares, you would end up with a bell curve, what looks like a mountain, with a peak in the middle, and on the left and right edges you'd have sort of a trailing off slope that would go off infinitely. That's how you create a bell curve. Now, the central limit theorem is a theory about the implications of a bell curve on reality. And there are 2 implications. The first is that extreme outcomes occur with very low frequency, which is sort of obvious. If you were to rerun World War II 1,000 times, how many times would Hitler have prevailed? Probably very few, because of the overwhelming odds against the expansion of Nazi Germany. Number 2, highly unlikely events are more likely to occur as numbers we are observing are smaller. So if we had a bell curve made up of 1,000 events, very unlikely Hitler would have won. But if we have a bell curve of only 9 events, it's actually more likely that a discrete block of victory would have occurred in that block. Now, why does this matter for us? Right? The idea that if events occur in small numbers, you're going to get far more variance than if you have few numbers. Well, it comes down to how we select our cases, okay, which I'll show you in the next slide. Here you can see a normal bell curve. You can see the peak in the middle, where events are most likely, and on the tails on the left and right, where they're least likely. So, in February 27th, 1991, a Scud missile was launched by the Iraqis against an American base at Dhahran. The missile is very inaccurate. But in this one instance, it landed on a barracks in Dhahran, housing U.S. Air Force personnel, and it killed 28 American soldiers and airmen and airwomen, and wounded 100. Enormous loss. The consequence was that the U.S. put billions of dollars every year for the next 2 decades into missile defense. Now think about it. What was the logical conclusion from this attack? If 1 million Scud missiles had been fired at Dhahran, the likelihood of a missile hitting the barracks probably would have been 0. These missiles are incredibly inaccurate. So the probability that a missile would have hit that barrack is virtually 0. The policy conclusion, however, was different. Because of this 1 in a million strike, huge amounts of money were misspent to save lives that'll probably never be lost again under similar circumstances. This tells us that when we choose a case, we have to situate the case in terms of its likely probability. If you look here in terms of the total losses that the U.S. suffered during their 1991 attack on Iraq's soldiers in Kuwait, you can see the U.S. lost soldiers in the air war, soldiers in the land war, a lot of soldiers in accidents. But in terms of combat losses, about 1/3 of their losses occurred in that one single strike. So when we choose a case, we have to ask ourselves, what is the likelihood of this case ever occurring again? And therefore, is it the type of typical case that we want to test on? If we were to test World War II as a case of an extremist political dictator trying to win a war, how likely is it that Hitler would have won? And therefore, how useful of a case is World War II for that type of test, where we're testing a dictator that had an even chance of winning? Perhaps Napoleon or Louis XIV had a much better chance of winning than Adolf Hitler. So it matters what the likelihood of that case would have been if we'd run that case over an infinite time and created a bell curve and then estimated the likelihood of an outcome. Now, I should sort of put as a backdrop assumptions about determinism in this class, but that will come up when we have our lecture on statistics.